Let's do some problems related to F test. So please read this question well. The standard deviations calculated from two random samples of size 9 and 13 is given as 1.99 and 1.9. So let's write what is given. Standard deviations calculated from two random samples of size 9 and 13. So n1 is 9, n2 is 13. Okay, and standard deviations, that means S1, small s1 is 1.99 and S2 is 1.9. Then can the samples be regarded as drawn from a normal population with the same standard deviation? So we need to check, we need to test whether these are drawn from two population with same standard deviation. Okay, so here it is null hypothesis we will take as H0, that is sigma 1 square equal to sigma 2 square. So from the question only you will get to know which test you need to use. So with same SD, same standard deviation means we are putting equality sign against the alternate hypothesis HA. This is sigma 1 square not equal to sigma 2 square. So from this, see here table value is given 0.025. So here what could be the level of significance? Will be double of this one. That means here two tail it is given. So as I have shown you earlier, this rejection region will be here. Okay, if you draw the curve like that, rejection region will be on these two parts, means it's a two-tailed test. Okay, then so 0.025 here, 0.025 here, so total it will be 0.05. So its actual level of significance is 0.05, being a two-tailed test, that is split into two. So values are mostly, in most of the cases in question only, they will give the table values. Okay, so this is given. Now second we will calculate the statistic. So calculation of the test statistic. So here we will calculate F is equal to S1 square upon S2 square. So here you can see S1 is more and S2 is more, means this standard deviation is more than this one. So here I am going to use S1 square upon S2 square. So already like we had done on this previous day, larger sample variate upon smaller sample variate. Okay, so sample variance upon smaller sample variance, that means S1 square, capital S1 square upon small capital S2 square. So that is otherwise N1 S1 square upon N1 minus 1. Please refer the previous lessons notes before solving this one, and this will be N2 S2 square upon N2 minus 1. So that is F is equal to N1 is 9 into 1.99 square, N1 S1 square divided by N1 minus 1, N1 is 9 minus 1 8 divided by N2 S2 square 13 into 1.9 square divided by N2 minus 1, 13 minus 1 is 12. So while calculating this one, you will get it as 4.455 divided by 3.91, which is equal to 1.139. Okay, so this is calculated value of F. Now third, it is level of significance. It is given alpha is equal to 0.05. It is not given here, but we can make it out from here. Being a two-tailed test, this will be level of significance will be twice of that one. So alpha is 0.05. Then degrees of freedom, nu 1 will be n1 minus 1 for the numerator, n1 minus 1 means 9 minus 1, 8 for the numerator, and nu2, n2 minus 1 means 13 minus 1, that is 12 for the denominator. So as already we had this formula, that is if sigma 1 square not equal to sigma 2 square, HA and H0 is sigma 1 square equal to sigma 2 square, then we calculate this. Okay, already we had discussed this yesterday. So that is, I will find out now the value, critical values. So critical values, that is F8 12, n1 minus 1, n2 minus 1, 8 12 at 0.025 alpha by 2. Okay, because 2 tail is equal to, it is given here for 8 and 12 with degrees of freedom 8 and 12, 0.025 is 3.51, and for F12 8 at 0.025 is given as 4.20. Okay, so as in the previous lecture we have seen, that is after finding out this one, f of n2 minus 1, n1 minus 1, n2 for us it is 13, 13 minus 1, that means f12 and 8, whatever the value of this one, you need to take the reciprocal of that. Okay, so 1 upon, therefore 1 divided by f12 8 is 1 divided by 4.20, which is given as 1 by 4.20 is 0.238. 0.238. Okay, so now we need to take the decision. So decision that is, here we got F calculated value. F calculated is 1.139, then F12 8, 1 by F12 8, this is equal to 0.238, and F8 12 is equal to 3.51. Okay, so if you look at all these three values, you can see this lies between these two values. That means if I look at the table here table is not necessary. So here this value, here it is 0.238 and here it is 3.51. Okay, this is 0.238 and this is 3.51, and 1.13 lies somewhere between that. 1.13. So that calculated value lies between these two. So our conclusion was also based on that only. If the calculated value lies between these two values, you need to accept H0. Okay, so here F calculated value lies between 1 upon f of alpha by 2, that means this 12 8 is less than 1 upon, f of, not 1 upon, f of 8 12. Okay, so therefore we accept H0. We accept H0 means, what was H0? H0 means it was sigma 1 square equal to sigma 2 square. So we accept the null hypothesis and we can say that the samples can be drawn from, therefore the samples can be regarded as drawn from population with equal standard deviations. Okay, so this is first type of problem, that is if sigma 1 square equal to sigma 2 square, how you have to solve this question. This is the way to solve this. So this is question number 1. Now we will do another question. See this question. In a test given to two groups of students drawn from two normal population, mark obtained were as follows. examine the equality of variances. So here also you need to find the equality of variance, means sigma 1 square equal to sigma 2 square, that you have to see. Okay, so here group A is given, group B is given, only this data x1 x2 like that it is given, and this is also given the table values. Okay, so here see at 5% LOS, here you need to check equality of variance. So here I have to check H0, this is my null hypothesis. Null hypothesis H0 is sigma 1 square equal to sigma 2 square, and alternate hypothesis HA is sigma 1 square not equal to sigma 2 square. Okay, so here this is what we want to check. So it is two-tailed test. So 0.05 is divided into two parts, 0.025 and 0.025 to the right, and left values are also given, table values. Now here this only this x1 x2 like that values are given. So here what we are going to do is, so second is here test statistic. So test statistic means that is f is equal to n1 s1 square divided by n1 minus 1 upon n2 s2 square divided by n2 minus 1. So here this s1 and s2 is not given, so we need to calculate that one. So for that we will calculate here now. So in the first lecture already we had discussed, that is s1 square is summation of xi minus x bar the whole square divided by n1. Okay, so from the data given here you will find out this one. So summation of xi minus x bar the whole square equal to n1 s1 square. You needn't show this in your answer paper, or this is not necessary to write again because already we know this formula. So directly instead of n1 s1 square you can put this value. So similarly n2 s2 square will be summation of yi minus y bar the whole square. So we need to calculate this now. So for that move back to your question, this one. So draw the table again. In the question it is given like this, and while doing the answer you need to draw a table. So suppose I am taking this is xi and this is yi. Okay, then here total sum of this x bar I have to find. X bar will be sum of this all divided by n. So n means how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here n1 is 9 and here n2 is 7. Okay, so x bar means sum of all these values divided by 9. When you do that you will get x bar is equal to 37. Similarly, when you do this one, sum of all this divided by 7, you will get y bar as 34. Means find the sum of all this, divided that by 7, you will get 34. Now next column is xi minus x bar you have to do. So I hope you remember in the last 2-3 chi-square problems we did the same way. So this is xi is given, x bar is 37, next column is xi minus x bar. So 18 minus 37. Okay, 18 minus 37, that is minus 17, minus 19. Then minus 19 square. So here directly I am going to write the column as xi minus x bar the whole square. So first of all you will find xi minus x bar, then xi minus x bar the whole square. So 19 square is 361. Here you will get again 20 minus 37 minus 17. Minus 17 square is 289. Now here it is 1, here it is 169, 144, 19, means here the difference is 12, 12 square is 144, and this is 16, and this will be your sum of xi minus x bar the whole square. This is 1134. Similarly, I will write here yi minus y bar the whole square. So in the same way, you will get here 25, 36, 64, 1, 16, 100, then 144. This total you will get, sum of ya minus y bar the whole square you will get as 386. Okay, so this is the way to do. Then now we will substitute that in this value. So f is equal to n1 s1 square. So n1 s1 square by n1 minus 1 upon n2 s2 square by n2 minus 1. So instead of this n1 s1 square, I will write here summation of xi minus x bar the whole square divided by n1 minus 1, and here summation of yi minus y bar the whole square divided by n2 minus 1. So xi minus x bar the whole square is, this is 1134 divided by n1 minus 1, n1 is 9, 9 minus 1 8, by this is 386 divided by n2 is 7, 7 minus 1 is 6. So when you simplify that, you will get it as 2.203. This is f calculated value. Okay, so now third one, level of significance is given as 5%. Then degrees of freedom is also given as, new one is n1 minus 1, that means 9 minus 1, that is 8, and new 2 is 7 minus 1, that is 6. Okay, these are the degrees of freedom. Now table value is given, f 0.025 at this 8 and 6 is given as 5.60, and f68 at 0.025 is given as 4.65. Okay, so now what we have to do is, this is f of n1 into n1 minus 1 into minus 1, this is f of n2 minus 1 n1 minus. So I will take the reciprocal of this, reciprocal of f68, therefore 1 upon f of 68, this is equal to 1 upon 4.65. When you simplify, you will get that as 1, it is 0.215. So this value, and the calculated value, you can see that 0.215. so now decision 0.215 is here, then 2.203 is there, and this is 5.60. so this calculated value, this is f calculated value, this is 1 upon f of 68, and this is f of 86. Okay, so this calculated value lies between these two values, therefore we accept H0. We accept H0 means the variances are equal. Okay, so that is second one, that means we accept the null hypothesis. Now let's do another type. So all these are different types of questions I am doing. So next one type, this, read the question well. Following results were obtained from two samples, each drawn from two different populations A and B. Test the hypothesis that the variance of A is less than variance of B. So from the question only you can write what is the null hypothesis. So here the null hypothesis is H0 is variance of A is less than or equal to variance of B. That means I have to check sigma 1 square is less than or equal to sigma 2 square. So alternate hypothesis will be HA sigma 1 square is less than sigma 2 square. Okay, So now the test statistic. That is f is equal to n1. Now sample size here, this is n1, n2. Sample standard deviation, this is 4, S1, this is S2. So S1 square is greater than S2. Please check this also. So S1 square is greater than S2 square here. Okay, so n we will use n1 S1 square upon n1 minus 1 divided by n2 S2 square divided by n2 minus 1. So this is comparatively an easy problem. So now just put the value of n1. n1 is 25 into S1 square. So that is 25 into 4 square divided by n1 minus 1. That is 25 minus 1 is 24 divided by n2. 17 into S2 square, 3 square 9 divided by 16. Okay, so while calculating this, you will get this as 1.74. Now here level of significance. Alpha is, it is not given anywhere, but here see table values are given, table value is given. So here alpha is 0.05. Okay, alpha is 0.05 means 5%, 0.5, and the value or degrees of freedom nu 1 is 25 minus 1, that is 24. Nu 2 is 17 minus 1, that means 16. So nu 2 is 16. Therefore table value, critical value that is F 2416, that is equal to 2.24. It is given there at 0.05 degrees of freedom. Okay, so now critical value you got, therefore now decision. So here nothing more to do because it is a direct, very direct question. Sigma 1 square is less than or equal to sigma 2 square, that is left tail test. So you need not find out anything else. So decision is here F calculated is 1.74, F table value is 2.24. So obviously F calculated is less than F table value. Okay, therefore H0 is accepted. H0 is accepted means the decision we are taken is correct. That is variance of A is, that is variance of A is less than or equal to variance of B. Okay, so this is the third type. Now let's do one more, that is the fourth type. So here see, read the question please. Two different processes A and B are used to manufacture light bulbs. Samples were drawn from two populations and following results were obtained. Then here population is given, sample size, so this is n1, this is n2, this is sample SD S1, sample SD S2. Test the hypothesis that the variance of A is greater than variance of B. So first one, null hypothesis is H0, that is you need to test variance of A is greater than or equal to variance of B. We will take it as greater than or equal to. So sigma 1 square is greater than or equal to sigma 2 square. This is we want to check. So alternate hypothesis will be HA sigma 1 square less than sigma 2 square. Okay. Now second, calculation of test statistic. So here you have to check S1 square and S2 square. So S1 square is greater than S2 square. So S1 square is greater than S2 square. So here test statistic we will take F is equal to S2 square by S1 square, because this is a right tailed test. Okay, so then S2 square upon S1 square. So here this is equal to n1 n2 S2 square divided by n2 minus 1 upon n1 S1 square upon n1 minus 1. So substituting this n1 n2 S2 and n1 S1 and all, you will get the value as 0.74. Substitute the values here. N1 n2, n2 means 17 into 50 square by n2 minus 1. So it is 0.74 is the calculated value. Okay, so when you substitute all this one, n2 s2 n2 minus 1, substitute all that, you will get this value as 0.74. Now the level of significance. So third one, level of significance, alpha is given as here in the table value, means table value here it is given as f 0.05. Okay, so alpha is 0.05, that means 5%, and f of table value is given as f is 2.21 for 1619. 1619 it is given as 2.21. Then critical value. Critical value is f 1619 at 0.05 is 2.21. So now what we do is, you have to find reciprocal of this one. F 1916 will be 1 upon f 1619 only. We need to just find the reciprocal, that is 1 by 2.21. So this table value is given as we had already discussed here. See, if it is sigma 1 square is greater than or equal to sigma 2 square, then what we have done here, it is f of n2 minus 1 n1 minus 1 is given. N2 minus 1 n1 minus 1 is given. So then we find, suppose its value is f alpha, then we find the reciprocal of that value. Okay, so here that is given, f of 1619 is given, you just find the reciprocal of that one, that is 1 upon 2.21, this is equal to 0.45. Okay, now f calculated value. Now the decision you have to take, decision is f calculated value, we have it as calculated 0.74. Okay, so f calculated is 0.74. This is greater than this value, this 1 upon f of 1619. It is greater, calculated value is greater than this table value, that is the table value f of alpha, whatever that is. Okay, so f calculated value is greater than the table value, therefore what we will do there, then if f calculated value is less than 1 by f of alpha, if it is less, we reject. So here you got it as greater, so we need to accept it. So we accept H0. So what was H0? That is variance. The variance of A is greater than, variance of A is greater than variance of B. Okay, so this is a way to do this one, especially the last problem. This problem you need to give more stress because here we are finding the reciprocal and all, so be careful while doing this type of questions. Okay.